To describe the motion of an object, we're going to need to develop a model, which is a simplified pictorial and mathematical representation of a system or an object. What we're trying to do is to capture the essential elements without getting into too much detail. For this part of the course, we are studying kinematics, which is a descriptive model of motion. We are describing how an object is moving without worrying about why it's moving that way or what put it in that motion. We're going to be using the particle model here. In the particle model, we represent the object as a particle, and we can follow where that particle moves, and wherever the particle moves, we know the rest of the object moves as well. So for example, if we have a little car here, we're going to treat the car as a particle, and wherever that car moves to, we know that wherever the particle goes, the car should be there as well, but tracking the particle itself is simpler than going into all that extra detail. To turn our observations of the location of the object into mathematics, into something we can calculate, we're going to use a motion diagram. We always want to start with a diagram to represent and describe our motion. A motion diagram is going to tell us what direction the object's moving in, how fast is it moving, is it speeding up or is it slowing down. It helps us find all of those things about the object. What we're going to do when we create a motion diagram is, number one, to model the object as a particle. We'll observe where the object is and record where that particle is in equal time intervals. When we're watching something, we might do it every 1 second, 0 seconds, 1 second, and 2 seconds. If we're using a computer, we might measure every 10th of a second, every 100th of a second, and the like. Once we have the particles representing the location of the object, then we'll add a coordinate system. That coordinate system consists of a coordinate axis. For one-dimensional motion, we're going to have motion along a straight line. This is our coordinate axis, and our coordinate axis has to have a coordinate. That's the variable that we're going to use to describe the motion, and the units, and we're going to put the units in square brackets. So if we have linear motion, straight line motion in the horizontal direction, usually our default is to use the variable x to represent that horizontal motion, and we will default to using meters for that motion. To actually describe where the particle is at each instant, we also need an origin. The origin is going to be our reference point. It's completely arbitrary, but it's the 0 point, it's the location where x equals 0. Once we have the time variables telling us when the object was at each location, we're going to use our coordinate system to measure the spatial variable, measure the position, the location of the object at each point in time. We'll be able to come up with ordered pairs. And once we have ordered pairs, we can make a graph. You can imagine with this data here, as time moves on, time is our independent variable, x is our dependent variable. We can see that at time t equals 0, we're at a location of 1. At t equal 1, we're at a location of 2. And at t equal 2, we're at a location of 4. And so we can use that information to describe how the object is moving and use that analysis to describe where the object has been, predict where it will be in the future, and so forth. The last thing that we're going to need to know are vectors. These are a mathematical construct. We're going to see this in much more detail later on, but for right now, all you need to know about vectors is that it is a mathematical quantity that has two parts. It has a magnitude or an amount. That magnitude is always positive. But a vector also has a direction, and we describe the direction with a plus or a minus sign. So, for example, if the object is moving, we would say that the magnitude is the speed of the object, it's how fast the object is going at an instant, but we would use a sign. We would say that the object is moving at plus 10 meters per second, means it's moving to the right because that's a positive value. If it's moving with a speed of negative 10 meters per second, that means it's going the same speed but going to the left because the negative sign means to the left. We can also use an arrow to describe this is an object moving to the right, that's an object moving to the left. The longer arrow means a bigger magnitude, the shorter arrow means a smaller magnitude, and the direction is in the arrow.